But first, we'd like to say just thank you again for the opportunity to present in the Library Science Talk series. As he mentioned, we're here to share our experiences regarding the integration of these two services at CDL, namely how we re-engineered the integration between these two, Merit and also Dryad, which houses open access data sets. It's basically been an opportunity over the past, and this integration took place about a year ago. And we've been tweaking it ever since. You'll see some recent developments that we'll call out near the end of the presentation. But it's lent us an opportunity to not only streamline the connections between the services, but again, to ultimately provide tools on top of which partner organizations such as the affiliated organizations of the campuses at UC and also throughout the state of California to build on top of the repository. So we provided them methods with which to acquire the content in the repository in terms of like master copies or otherwise when they would like to. So that part of the interaction with the repository has been streamlined also. In terms of Bright versus Dark Archive, before the integration, there were only handfuls of people who had access to any given collection. There are about 354 collections in Merit right now. So it was a very restricted access type platform. However, now after the integration, it's more like a light archive, which enables an increased amount of user interaction. So let's talk a little bit about Merit. It's a Core Trust Seal certified repository that is whose code base is open source. It's maintained by UC3, as Tulio mentioned, at California Digital Library. We have 3 independent copies and 3 different cloud-based storage providers across 2 geographic locations with differing disaster threats. So we have 1 copy on the East Coast of the United States, and we have 2 copies on the West Coast of the United States, namely 1 down in San Diego at the Supercomputer Center there, and 1 up in Oregon and Amazon Glacier. The microservices that are part of Merit take care of a lot of, all of the typical functions of a repository that you might think of, including ingest, handling the storage, shuffling things around, taking care of inventory, keeping track of all of the objects in central database, of course, auditing or fixity checking, and replication across the different cloud services. Who are our users? Merit serves the librarians across all of the different UC campuses, and of course, it serves the researchers on the campuses, but with the integration with Dryad, it serves researchers from around the world who would like to deposit their data sets in Dryad for open access. The libraries, as I mentioned earlier, also work with affiliated organizations, memory organizations such as museums and otherwise. And then we have an e-scholarship platform at the CDL as well. This is our journal publishing platform, and we publish 85 different open access journals at CDL. So all of that content from the journals is also being preserved in Merit. And of course, the open access data sets from Dryad. To start talking about the integration between these two services, we really need to kind of start at the root of the integration, which is how Merit manages its content. It manages individually, it manages the files and the objects in the system, as opposed to just, for example, managing the container file itself. It will manage each individual file inside the container and in turn provide a way for versioning any of that content that we'd like. So just to plainly state it here, a file being a single digital file versus an object being 1 or more digital files plus metadata to describe that object. And of course, the metadata can be within the object as a separate, say, for example, mods file, but there's also some Dublin core, like top level object metadata as well that's made available. So here, just a quick word about the different cloud services and individual files. We're going to have some diagrams that we'll talk through, and so these little bubbles and things will become familiar as usual. But SDSC is the San Diego Supercomputer Center, and it is running Cumulo storage. And that has a layer in front of it called Minio, which is actually an S3 compatible API layer. There's Amazon S3 and Glacier, and of course, Wasabi is a relatively new provider that we started to store content in. They are on the East Coast in Virginia. The important thing to note here is that each of these providers have an S3 compatible API. So we have essentially been able to use the same implementation in the Merit system to interact with any of these particular providers. There are 4 here, whereas we listed 3 copies earlier. It just depends which collection is at hand. Most of the collections have their primary copy at the San Diego Supercomputer Center, and then they have secondary copies in both Wasabi and Glacier. Some of the collections that require quicker access, such as the Dryad collection, such as our eScholarship collections, their primary copies of objects are in Amazon S3. So with regard to objects in Merit, again, these can be collections of 1 or more files plus 1 or more metadata files and some object level metadata as well. The key bit here being that all of these objects are being tracked via an archival resource key, an ARC. And the ARCs are minted at CDL as well by a separate service called EasyID. But every time something is ingested into Merit, we reach out to EasyID, which gives us back an ARC. And then we record that ARC in the central database along with the location of all the different content. So within Merit, I had mentioned versioning a little bit earlier. We perform forward delta versioning for all of our objects. So in other words, that means that when a new version of the object, or for in this case, a data set is submitted, we will examine which files are still the same and which files are new. And we will only ingest the files that are new, and we'll have basically pointers back to the existing unchanged version of the files. That's how we handle versioning and obviously save some space in the cloud. So now we talked a little bit about how content is managed within Merit. Let's talk a little bit about the actual range of different file sizes that we're handling in Merit as well. You can see here on in the top area, the top chart, the maximum file size that we have for any individual file. This is not an object, it's actually a file. It's 289 gigabytes. We have many 0-byte files on the other end of the spectrum, and then the average file size that we're handling is about 8.5 megs. The producer files in the system right now amount to about 20 million or so different files. There are many more system files that are in the background, and when I say system files, these are little files that record the electronic resource citation type information, when things were ingested, that sort of thing. And so altogether, there are over 50 million files being tracked. The lower table here, under a megabyte, obviously we have 17 million files, but again, that sweet spot's around 8.5 megs in the middle. The reason we're mentioning this is because the system really has to be able to handle any of these files, meaning ingesting any of these files and being able to provide them for download or retrieval. So let's discuss Dryad some. Now that we're familiar with Merit, Dryad contains about 34,000 different data sets from about 2,000 different institutions, and they've been submitted over the years from about 100,000 researchers. The integration we're talking about here, like I said, started about a year ago. The partnership between CDL and Dryad started a few years ago, and there was, about I would say about a year of working together before we started on this kind of re-engineering effort that we're talking about today. Every data set moves, once it's been submitted to Dryad, it moves from Dryad into Merit. The data sets are importantly replicated to Zenodo as well. So that's a relatively recent feature that the Dryad team has worked with CDL to implement and worked with Zenodo. So once everything is settled in Merit, then as I'll mention a little bit later, give you a little bit more detail about how that works. We stage everything and upload yet another copy to Zenodo, and Zenodo provides us with an additional DOI that can be used to track that data set. It's important to mention that Dryad generates the majority of access requests for Merit, because every single time that a user goes to the Dryad user interface and says, I would like to download a particular data set in its entirety or an individual file from the data set, Merit has to be part of that interaction. And so there's a lot of traffic going on the system itself. The other high traffic generator is, of course, eScholarship with all of their journals. If you'd like to visit Dryad, they're at datadryad.org. And here is a little bit later, if we have time, we'll actually go to both of these sites. We'll go to 4 sites. We'll go to the Dryad, we'll go to Zenodo, we'll go to Merit, and also to the actual publication in a different journal. But this is a snapshot of one particular Dryad data set. There's, of course, a little bit more below the fold here, below the abstract. But what you'll note here is that there is a DOI, and then the data files section on the right-hand side shows you can download the entire data set or individual tar files in this case. And then interestingly, in the related works down here, of course, there's the article that's mentioned, but another new feature that we've worked with Zenodo to implement recently is uploading software. So whenever there is the occasion for software to accompany a data set, and the researchers or the folks who have put together the data set would like to upload that software can now be uploaded for safekeeping directly to Zenodo. Here's a snapshot of the Merit user interface. It's a little more utilitarian, but again, you can see the same under the local ID field. You can see the same DOI that was mentioned for the data set over in Dryad. The versions that are in Merit can actually be a little bit different than the number of versions that are in Dryad. So every data set that goes into Dryad is curated. They have a team of curators that work with the authors of the data set, and they essentially jointly decide on which versions of the data set will be shown on the Dryad side. So Terry's going to talk a little bit about how the two systems were initially integrated, and I'll let him take over for the next few slides.
So in Merit, we have 2 primary forms of content retrieval that we need to support. The simpler form of retrieval is user requests a single digital file. That digital file is in cloud storage, and we download that and provide it to the end user. Now, Merit has historically sort of brokered content between multiple cloud storage providers or even precursors to cloud storage. So initial implementation of the system was that a user would request content, a particular file. In the case of Dryad, they would request that through the Dryad user interface. That request would get sent to the Merit user interface, which would get sent to the Merit storage system, which would find the content in the appropriate cloud storage location, and then stream the digital bytes back through that same stack of applications, resulting in the file being available to the end user's browser. Our next form of content retrieval is a bit more complicated, and this is when a user requests an entire object or version to be downloaded. In this instance, we've got multiple files, both digital files and some supporting metadata that need to be assembled into a container, and then that container needs to be downloaded for the user. So we had 2 different workflows to support an object retrieval. The first request would be the user would initiate a request from their browser to the Dryad user interface saying, I would like to download an object. That would get sent to the Merit user interface, which would send the request on to the Merit storage system. That would then assemble all the component parts from cloud storage into a container, such as a zip file or a tar file, and then stream the bytes of the container file back to the user through those individual applications. And the majority of requests went through what we call the normal workflow. For exceptionally large objects, over a few gigabyte or over a few gigabytes in size, we had an asynchronous object retrieval process. In this instance, the user's request would flow through the same stack of applications, but instead of streaming the container file back to the user, the Merit storage system would assemble a container file in cloud storage, and at the point that the container was ready, an email would be sent to the user indicating that the content was available and then providing a download link, allowing the user to download the container directly from cloud storage.
So with regard to how this initial integration was operating, and the major hurdles that we had to address were these potential long-running operations for both content being ingested, very large content being ingested, as well as that same content being downloaded. We had, as mentioned earlier, there's a lot of traffic going on, so we had multiple simultaneous downloads occurring through the Dryad front end that the system had to be able to handle on its own through streaming through all the different applications and services that Terry mentioned. And then, of course, we're talking about every byte. The requests, we're talking about either the tar files or the zip files, the individual files. So, all of this was happening all the time. And eventually, with the introduction of the Dryad traffic, the additional Dryad traffic, we found ourselves spending a lot of time, I would say, chasing down small problems, sometimes big problems. It was very time intensive for us. So we knew we had to make the system more resilient. The large files, for example, that 200 plus or 200, I think it was 89 gigabyte file that I mentioned earlier, or large objects. Sometimes objects can actually have hundreds of thousands of files in them. There have been times where an individual campus has asked us to snapshot, of course, entire hard drives as a single object, which we try not to do, but that's happened in the past. And those uploading and downloading those types of objects can be very, processor and IO intensive on the system. And then, the other thing to mention here is that when we would like to update the system, we would have to be, we're still, and we even more so in the past, we would have to be very cognizant of the content that's coming into the system and wait, of course, until that content was finished ingesting or content was being delivered to an end user. We'd have to keep an eye on that sort of thing too before we would, shut down the individual hosts to update their software. The good thing is that most of the microservices in Merit are high availability, so they have multiple hosts running the same software. So of course we can rotate, take one offline while another one is still serving traffic, et cetera. But specifically for the storage systems and the ingest system microservice that's taking in new content, we can't do that until all of that activity has actually calmed down and stopped. The other note to mention about those emails and the original asynchronous workflow, where the storage service would put together and zip up an entire object in cloud storage and then make it available via an email and a link to the end users. That, of course, there were some emails that never made it to the end users because of their domains. That email may have been blocked, and we had many folks who would just end up contacting the curators directly and Dryad directly, and while attempting to obtain their data sets because, well, they were actually there to obtain, but they never received the email notification. So that workflow needed to go as well. Terry, you want to take over and keep talking about the re-engineering access, the new integration that we're building?
Sure. So we needed a dependable way to stream content to the end user, but our goal was to have the end user stream directly from the cloud provider rather than flowing all those bytes through our applications. And a solution that Amazon S3 makes available is the notion of a pre-signed URL. And I'll describe what that is. But fortunately, all three cloud providers we're utilizing right now support this this particular storage feature, and it's been really useful for us. So I'm going to give you a quick illustration of what a pre-signed URL is. I'm here at the top of the slide. I'm creating a file called hello.txt and putting in there the content hello there. On the next line, what I'm doing is copying that hello.txt file to Amazon S3. So that's that AWS S3 copy command. And in the process of copying this content to S3, I'm also setting an access control list flag on the content saying that it's available to the public. And on the third example here on the slide, I am then retrieving that content directly from S3 using the curl command. So I'm retrieving the content, and you'll see that my message hello there is appearing. So that's an example of just accessing a publicly available bit of content on the internet. Let's go to the next slide. So in this example, what I'm doing now is copying our file hello.txt to S3, but I'm assigning the file the name nonpublic.txt. You'll also notice I'm not setting that public access control flag when I copy the content to S3. If I attempt to retrieve that file directly from S3, I'm getting an access denied error down below. And that's because no public access has been granted. So on the next slide, what I want to show you is AWS compatible storage providers or AWS API S3 compatible storage providers that provide this pre-signed capability allow you to generate a pre-signed URL for your content in cloud storage. So I'm asking AWS to return to me a pre-signed URL, and you'll see the pre-signed URL looks a bit like the original URL, but has several other components to it. And one of the key components it has in it is an expiration date, or this expires flag. But what this URL will do is give me temporary access to retrieve that content, even though the content is not publicly available. So on the final example here, you'll see I pass that pre-signed URL to the curl command, and I am able to read the file directly from S3. So the way we were able to take advantage of this was, you may remember before we would direct a request all the way to our Merit storage system and then stream the bytes back to the end user. With the new solution, what we do is we flow the same request down to our Merit storage system, but then inside the storage system, we ask the storage provider to return us a pre-signed URL. So the lightly shaded arrow sends the pre-signed URL back to the end user, and the end user's browser redirects the user to that pre-signed URL and streams the digital content directly from the cloud provider to the end user. And that then puts the burden of much of that bandwidth on the cloud provider themselves. This also enabled us to re-engineer the object retrieval process. So you may remember we had two distinct workflows before, one that streamed all the bytes through our stack of applications, and the second approach, which relied on email as a notification mechanism. And what we were able to do is re-engineer the process so that all requests, regardless of object size, would follow the same workflow. They all essentially became an asynchronous process. So what would happen is a user would request an object to be assembled and retrieved. And at the point that that request was received, so that's the red arrow is the user requesting an object. The green arrow flowing back is our storage system returning a token to the user's application. That token then allows the user to periodically pull our services to see if the content assembly is complete. Once the content assembly is completed, the user is able to send that token in and retrieve a pre-signed URL for the assembled object, which has been assembled in cloud storage. And at that point, the user is redirected to the pre-signed URL and is able to download the entire container file. And this had, in addition to us being excited to have a single workflow, this made our servers more stable, more reliable. And on the next slide, we'll show you some of the results of that. So our CPU utilization and network I/O were quite high before we implemented this change. And after we made this change, our CPU utilization was moderately reduced, but our network I/O traffic was greatly reduced. And the following slide will show you what that looked like on our performance graph. So here you'll see on both of these slides a before and after image of some of the metrics from our servers. So CPU utilization, as I said, made a modest decline, but really pretty consistent decline after the software release. But on the right-hand side, the network I/O graph, you'll see a significant change in traffic because we were offloading the majority of the network I/O to our cloud providers. And somebody had asked about coding language. I think if we're asking about the coding language in that pre-signed example, those were just used Linux commands using the AWS S3 API from the command line. Our actual applications are written in both Java and Ruby, and we make some calls to Amazon directly from both of those languages.
So going forward, what about user uploads? Throughout this presentation, we've been talking about obtaining the content and how we re-engineered that by using pre-signed URLs, so the content flows directly from the cloud to the end users. However, the Dryad team has actually recently gone further and decided to use pre-signed URLs for uploading content as well, so they can enable a user to, from their browser, literally upload their content from the data set directly to the cloud, instead of having that data travel through all of the different subsystems that we're talking about. So with regard to how that works, there's an AJAX call to authorize the actual S3 upload. And then the Dryad team is using a library called evaporate.js, which will take the content and chunk it down into smaller bite-sized chunks, portions of data, to make sure it all uploads correctly, and it can track it in case there are fluctuations in the connection. And then upon upload completion, there's another command that's run, which actually on the AWS side reassembles all of those parts into a cohesive whole. And once that is done, what Dryad will do is deliver what we call a manifest file to Merit that says, oh, here is the location of that reassembled object, and now Merit can actually go and grab it for the ingest process to start into the repository. So this just went live in March, and they're very happy with that process. It has also taken some of the load off of their systems as well, which has been really nice. We've mentioned a bunch of times that we're working with Zenodo, and the process that takes place to actually move data sets to Zenodo is pretty much what I mentioned earlier. Once everything is settled and between Dryad and Merit, we will actually use pre-signed URLs to obtain the content and stage it first. Once it's been staged, we will stream that content up to Zenodo, at which point they generate a DOI for that new data set, and then the original DOI that was created for the Dryad object is also sent to Zenodo, along with metadata and information about the data set. So the data sets can, of course, encompass anything that was related to the research project, but now that we're also offering the notion of uploading software, there is a separate step in the data set submission process when you go to the Dryad user interface, which says, Would you like to upload content that is in the form of software content directly to Zenodo? And you'll have a chance, excuse me, to select all of those software-related files to upload to Zenodo. A couple of notes about what we'd like to do for the future in Merit. Of course, we're learning from the Dryad team's experience with uploading different files and using pre-signed URLs. Their use of the JavaScript library to do that will most likely not be our process, because our microservices are written in both Java and the front end is in Ruby. However, we would like to implement that, and so we'll have both Dryad users able to take advantage of that kind of process, but then we'll also have all of the different librarians and archivists and folks who ingest content directly into Merit. They'll be able to take advantage of that sort of thing as well. So this goal of refined integration between Dryad and Merit is really what made us that was the impetus. That was what we wanted to do. It started the process of making these improvements, but the API endpoints that allow you to now access the individual files and also request individual objects via use of the token that Terry had mentioned earlier. Those endpoints are essentially out there for any of our campus users and anybody who's interested in using the system that way, and they're serving as building blocks for the end users and other development teams to actually use as a layer that they can essentially build their own front end, build their own, for example, library exhibit, where perhaps there are of course derivatives and display only images, but then they could also allow the folks who are looking at those exhibits to obtain the high resolution preservation copies by going directly to Merit through the API endpoints, if they would like to. So with that, let's check
Eric,
the time.
we've got two questions here in the
Okay.
chat. So
Right,
the first question is, did your cloud provider bill increase? And we did an analysis of the impact of switching to pre-signed URLs before we released that change. The two most significant costs are both storage of content, and the second most significant is the bandwidth cost of downloading the content from the cloud provider. What happens is, with the old approach and with using pre-signed URLs, we're essentially the fundamental storage of the initial content is the same, and the bandwidth charge, we get hit with that whether the people are retrieving content with the pre-signed URL or whether we're streaming that content through the applications. So those two biggest components of our bill did not increase. We do, for the purpose of those object assemblies, we make a temporary additional copy in cloud storage. So there is a slight increase in cost. To mitigate that, we set a pretty aggressive purge policy on the bucket where we store those assembled objects. So we create a pre-signed URL. Content is accessible for a finite amount of time, and that's really for security to not make those pre-signed URLs persistent indefinitely. The other thing that happens is, after, say, I think we set the policy at a week. After a week, any assembled objects are purged from cloud storage, and by sort of being aggressive about getting rid of that content. While there was a small increase, that was one that wasn't significant. Theoretically, we reduce the processing needs of our compute servers. So we potentially could have downsized the instance types, but just for greater stability, we did not take advantage of that. So we didn't recapture actual budget money after making the change. And Eric, the second question, this one's probably for you. Do you have a specific agreement with Zenodo for datasets larger than 500 or 50 gigabytes?
Right. So what I can say, I don't know the exact answer to that, because the product manager for the Dryad service would, though. I'm happy to relay it. But what I can say is that each data set in Dryad can go up to 300 gigabytes. And that means that we need to be able to replicate that 300 gigabyte maximum to Zenodo. So I assume there is an agreement that has been, created to allow larger data sets to be uploaded. The 300 gigabyte limit is not, an individual research team is not limited to just one data set that way. If they have more data, they can, of course, file as many data sets or upload as many data sets as they would like. From that standpoint, for the campuses at the University of California, anybody who's affiliated with the campuses, because of this agreement between CDL and UC and Dryad, the Dryad service is free for them to use. And then outside of the University of California, there is, of course, a membership for Dryad that is created, and it is a service that is being charged for via Dryad to other folks outside of UC. There's an annual membership charge. But I would presume the answer to this question is yes. And again, I'm happy to follow up if you'd like. So yeah, if other questions come up, please feel free to unmute yourselves and ask us or use the chat. I think, Tulio, do we have a few minutes to go through the front end of the application?
Of course. Please go ahead.
Okay, great.
We are very interested.
Let's see. So let's see. Right. This is, I have a bunch of browser tabs open right now, and this is an individual data set, a relatively recent one from February that was uploaded. And you can see that, we have a DOI here that you'll once again be able to take a look at, or is being stored as a local ID in Merit. There are a bunch of different places to interact with the user interface on the right here, including being able to grab the tar files that I mentioned. There is the software that is at Zenodo. There is the article here that is referenced. And of course, there's the abstract that is available in a sample citation. If we go to, let's see, if we go to Zenodo, this is that link that I mentioned here. All of the information, the abstract, well, actually the information that pertains directly to these files is recorded here. And you can see that there is a Jupyter notebook. There are different Python files that have been uploaded by the researchers as well. They're all made available for download. The original source DOI is mentioned here for the Dryad dataset. And there are also citations provided. And then here's the new DOI that Zenodo generated for this particular submission with all of these software files. If we keep going a little bit farther, the link from the original Dryad dataset that goes to the article is made available. This is the link to the article or the article display. So this particular submission was not related to, or was not published in eScholarship. I mean, there are lots and lots of journals, as we mentioned, a couple of thousand different institutions using this. So the journals are also in the position of being able to, this is just kind of a side note, integrate directly with Dryad during the article submission process. So when, for example, an article is submitted by the author and they have a data set to submit as well, a lot of times the actual, excuse me, a lot of times the actual software or journal platform that's being used will have a plugin directly to Dryad. So while the author is uploading their content and making their submission, there tends to be an actual function of that software that will say, okay, I want to upload this content, the data set, to Dryad, and there's a direct connection between the publication platform being used to take in the article and Dryad, so that data set can actually already be provided that early in the process. While the article is undergoing peer review, the data set in Dryad can be embargoed during the peer review process. So of course, the data set and the article are going through peer review and not publicly available at all until everything has been reviewed and approved and adjusted, and reviewers have lent their input, etc. Moving on to the Merit UI here, this is the same data set that was uploaded to Dryad and it flowed into Merit. So I'm gonna make this a little bit bigger for folks to see. You'll see that if I go to the most recent version of this particular data set, I just want to show you all the individual user files. These are the producer files or user files that were submitted with the data set. Dryad also makes a couple of additional files there's one for DataSite, and then there's a Data1 manifest. And then here are the system files that I mentioned earlier. These are files that we can use to actually restructure the central database and Merit in case there's a catastrophic failure on the Merit database side. So if the database goes down and hopefully not, we do have, of course, a way to reassemble all the information through these little files, such as like this, for example, is a really small file. Here's the ERC. Yeah, so here's the electronic resource citation with just some high-level Dublin core metadata, and then like information about the ingest, when the ingest itself happened, and the notifications, and this is information down here about what happened during the ingest process, that sort of thing. So all these system files can be, are very helpful and important to us. They are also being fixity checked, just like the producer files that are, of course, being fixity checked. Let me go back to the previous screen. If we choose to download this object, that means we're downloading the entire data set, and we're choosing for that asynchronous process to happen in the background, the one that Terry had described. I will avoid doing this because this is 3 gigabytes, but I do have another data set that's on the side here that's 5 megabytes, which if I go ahead and click the download object button, and this is just this is the UI telling us that the object is being assembled on the cloud service provider side, and when it's actually ready, we'll receive a URL that is a pre-signed URL to download the container, which contains all of the data set. We can download that directly to, of course, the client, the end user, and that particular data set is obviously a zip file here. Let's see if I can, here we go. So it has all of the different versions that were present, and I'm actually not showing you this. I think I would have to share, well, in any case, there's a window that I have on my desktop now that shows all of the different versions of that data set within different folders. That's an example of the asynchronous download process.